Okay, this is UT Quest for physics. This assignment, more forces in 2D. The problem we're going to look at here is the car stuck in the mud problem. All right, what we have is we have a car and a tree and a rope tied to it. Instead of pulling the rope, you're pushing on the rope. And we're showed that this angle of deflection is, in this problem, 3.5 degrees. All right, let's do a free body diagram and see what's going on here. All right, so what we're looking for is we're looking for the tension in this rope. Okay, remember originally it's stretched horizontally. Then when we push or pull on the rope, doesn't matter, all right, it gets a certain deflection. So when I pull on the rope, I get kind of this V shape, symmetrical. All right, so let's put that into a free body diagram. And this is what we come up with as far as our free body diagram. And we've seen this before many, many times over. The fact that this is symmetrical is going to help us. But the main issue is we know that this tension and this force vector are all in equilibrium. That means all their components must equal 0. So let's look at the components going left-right in this free body diagram. That means that this vector, which is a component of this vector, and this vector was a component of T2, these guys have to be equal to each other. All right, so using a little bit of trigonometry, let's find out the magnitude of these and set them equal to each other. Okay, so T1 cosine theta has to equal T2 cosine theta. Well, what does this tell us? This just tells us that T1 is equal to T2. And that will always be true as long as your problem is symmetrical. This angle and this angle are equal. Okay, so let's go then to our vertical forces. And what do we know? We know that this guy and this guy plus this guy have to equal 0. All the forces go in this direction, have to cancel out all the forces in that direction. All right, so let's set up a mathematical statement of that. How do I get the magnitude of these forces? Well, I get that by the the sine function of the hypotenuse. The hypotenuse will be the tension. All right, so I have this vector, T2 sine theta, T1 sine theta, 2 going up, minus this applied force going down, have to equal to 0. Now remember in our first statement here, T1 is equal to T2. So I can combine these as like terms. And then I get here, okay, this is given in the problem, this is given in the problem, this is my only unknown. So we've got a simple algebra problem. All right, what is this distance given for in the equation? Does that help you? No. That is information that you do not need. So, extra information, just like in real life. Oh, one last thing on this problem that you need to know. A lot of students, they get this and they solve it right. And then the assignment has a cheesy little trick here. It says right here, it goes, oh, I want my answer in kilonewtons. All right, that is thousands of newtons. So once you solve for this t, if I take that t and divide it by 1,000, then I'll have my answer in kilonewtons. So you may be doing the problem right and just reporting it in when you punch the problem into the computer. You're probably putting it in newtons instead of kilonewtons. Cheesy thing, but there it is.